given that cotangent of alpha is equal to negative 3/4 for alpha in quadrant 2, and tangent of beta equals 8/15 for beta in quadrant 3, find the cosine of alpha minus beta. So let's start with what we're trying to find here. We're trying to find cosine of alpha minus beta. Now we have an identity for this. The cosine of alpha minus beta is cosine of alpha times the cosine of beta plus sine of alpha times the sine of beta. So this is what I'm looking for, which means I need to find out what cosine of alpha, cosine of beta, sine of alpha, and sine of beta are. And we can find that from these two pieces of information that are given to us. So first of all, cotangent of alpha is equal to negative 3/4. Well, let's think about what we know about cotangent. If we are looking at points on a terminal side of an angle, I'm going to go ahead and draw something here. Okay. Let's make this a straight line. Cotangent is an x-coordinate over y-coordinate. All right, and I'm supposed to get negative 3/4 for my second quadrant. So over my second quadrant, my x is negative, my y is positive. So I can go negative 3 and up 4. Okay, and that's kind of the point that I'm looking at. So here's our terminal side for our angle, and we can use that now to find the cosine and the sine of alpha. All we just need to do is kind of connect this down. We've got our x here is negative 3, our y is 4, and we've got now a right triangle, so we can kind of find this r value. Remember, r is the distance from the point to the origin. And using the Pythagorean theorem, we can get that this thing is 5. I'll show that real quick. Okay, this is r. We have r squared equals negative 3 squared plus 4 squared, which is 9 plus 16, or 25. So that's r squared, therefore r equals 5. So that's this side right here. And then we can use that to find cosine and sine of alpha. Okay, this angle was alpha. And, well, cosine is x over r. So that's negative 3 over 5. And sine is y over r. That's 4 over 5. Okay, and then now we can do a similar thing to find beta. Now, we have tangent of beta is 8/15 for beta in quadrant 3. Let's go ahead and draw another thing for that. So since tangent of beta is 8/15, and in quadrant 3, both x and y are going to be negative. And tangent is y over x. So I can make my y a negative 8 and my x a negative 15. Okay? And that gives me a point that is on the terminal side of my angle. So creating then this triangle, I can again find r. So I've got a negative 15 right here. I've got a negative 8 right here. And I can find r using my Pythagorean theorem. So r squared equals negative 8 squared plus negative 15 squared. And that's 64 plus 225, which is 289. And so take the square root and you get r equals 17. So now I've got 17 for there. And now I can say 9r cosine of beta, because my angle here was beta. That's beta. I probably should have drawn that up here as well. That was alpha. My cosine is x over r. So that's negative 15 over 17. Negative 15 over 17. And sine is y over r, and that just disappeared. But my y was, sorry, this was negative 15 over 17. My y was negative 8 over 17. I'm not sure why that disappeared. That's weird. And then we can simplify this. Okay, so we've got negative 3 times negative 15. It's a positive 45. And then minus 4 times 8, 32. Okay, all over 5 times 17, which is 85. And that simplifies to 13 over 85. And so that is the cosine of alpha minus beta, given that information.